Okay, so we're going to talk about a couple different things today. Factor by grouping for quadratics, and I'm going to talk about difference of squares. These are both review topics from Algebra 1, but we'll talk about how to apply them to some of the problems you have here today. So if you want to listen to the example and then go try a couple practice problems, I'll give you the problems that go with each set. We're also going to talk about how to rewrite expressions in quadratic form. So we're going to start with factor by grouping, which is when I have a quadratic in the form ax squared plus bx plus c. So you can see that I'm on the second page of the notes. I just crossed out this one for b. If you already did it, then maybe you want to write it on a blank sheet of paper, and we're going to talk about how to do this. So we're going to make our t-chart. We have a times c, which is 8 times negative 15, and then we have b, which is negative 14. So we are looking for two numbers that will multiply to make a times c and add to make negative 14. So this is negative 120 together. That's a lot of different factors that make 120, so it might take us some time. If it's negative, we're looking for one to be positive and one to be negative. So I have 10 and 12, that's going to give me negative 2. I just tried 6 and negative 20. 6 plus negative 20 equals negative 14. So I now have two factors that will work, which is 6 and negative 20. We're going to rewrite our middle, the negative 14x, as positive 6 and negative 20x. So negative 14x now equals 6x minus 20x. And now I have four terms, which allows me to do factor by grouping like we did yesterday. So I have my 8x squared plus 6x group and my negative 20x minus 15 group. So I'm going to go ahead and factor 2x out. That leaves me with 4x plus 3. And then here I'm going to factor out negative 5, which leaves me with 4x plus 3. And then we regroup 2x minus 5, 4x plus 3. So problems that will involve you doing this on your practice sheet, so 5-5 practice, are number 9, number 10, number 12 are going to be those types of problems. Now we're going to move on to difference of squares. So this happens when I have a number minus another number and both of them are squares. We're familiar with seeing x squared, but the truth is that we can do difference of squares with any even exponent. So I would just cut it in half and I would have both of those. So difference of squares tells me that a square minus a square is equal to basically taking the square root of each of those things, a plus b, a minus b. So in my example I've written here 25x to the 6 minus 16. If we take the square root of 25x to the 6, this is going to be my a squared. Then I'm going to get 5x to the third. So that's your a. If I take the square root of 16, I'm going to get 4. So that's my b. And from here I can rewrite this as 5x cubed plus 4 5x cubed minus 4. So this is a way that we can do this. You can do this with squares, but any even exponent allows you to do this. You're going to see example problems like this on the study guide. Numbers 4 and 7. The last thing that we're going to do together is talk about how to rewrite things in quadratic form. This is another example of that difference of squares, by the way. If you wanted to try that, you would end up with 8x cubed minus y cubed, 8x cubed plus y cubed. So how to write an expression in quadratic form. I was just mentioning in the last problem that anytime I have an even exponent, I can do difference of squares with it. It can kind of be a squared number. So the same thing applies here, is that anytime I have an even exponent, I can look into writing it as a quadratic. So any even exponent is the same as squaring something. So usually what I do is I look towards my second number, my middle term, which is x cubed, and that's going to indicate to me what will go here. So these kind of look like the format that we use is called U substitution. So it looks like u squared plus bu plus c. And in this case, sometimes there's an a, sometimes not. In this case, x3 would be our u that we substitute. So instead of having x to the 6 here, I would have 2 x3 squared minus x3 plus 9. So not much changes here, just that I've replaced x6 with something squared. So if I think back to my exponent rules, x3 squared would be equal to x3 times 2, which equals x to the 6th. So this works because 3 here is half of 6, which makes that a potential for a quadratic rewrite. If we look at the next one, I do have that even exponent here with x4, but 2x to the 3rd, that's not half of 4. That doesn't make it possible for me to do a quadratic. So your middle term has to be half. The example problems that we can do this with are on your study guide sheet. I guess we kind of covered this already with the other one. So not one on the study guide sheet. Practice packet. You're looking at 13 through 18. You want to make sure that they are factorable using that quadratic form. So just turning that first exponent into another exponent with a square. So what mathematically makes sense, but a couple of them might not be possible. So that's what we're working on today, is to finish factoring the ones that we have left on our sheet. And what we will move to doing tomorrow is being able to solve. So if you want to move forward, what you can start doing is looking at these ones on the back and practicing how you would factor them out. So kind of ignoring the 0 at this point, but how would I factor this down? Any of them that you think you can figure out how to factor. Same on the practice sheet. Any of these ones on the back if you want to try and practice factoring based on the factoring skills we have, and then we'll explain how the 0 comes into play later.